So, the topic is resistance in series and parallel. So, we know that in our household circuits, all the connections are in parallel, not in series. Why? Because in series, the voltage gets divided across each appliance, but the current remains the same across all. But in parallel, the voltage remains the same across all the appliances, but the current is divided as per the rating of the appliance. So, as per we know that resistances in series, the equivalent resistance R equivalent is equal to R1 plus R2 plus R3. So let us derive this portion of R1 plus R2 plus R3, and along with it, let us see the voltage divider rule. So for that, let us take three resistances. One voltage source is given here. A resistance R1, R2 and R3 are present. A current I is flowing, and this is the circuit. Now, as per Ohm's law, the total resistance of the circuit, if I consider it as R, and if I is the total current flowing in the circuit, then from Ohm's law we get V equal to I into R. But since across each series resistance there is a separation of voltage, there is a difference in voltage as per the appliance. So let us consider V1 voltage flowing across resistance R1, V2 across R2 and V3 is across R3. So V1 is equal to I into R1, V2 is equal to I into R2, V3 is equal to I into R3. Now, this total voltage, this is the total voltage of the circuit flowing in the circuit. This total voltage must be equal to the sum of the individual three voltages across the three resistances. So, if I replace V with IR, then V equal to IR, and here I into R1, I into R2, I into R3. Well, now if I take common I, then it will be R1 plus R2 plus R3. So if I cancel out I from the both sides, we get R equal to R1 plus R2 plus R3. So this is it. This is the equivalent resistance when three are connected in series. Now, along with it, let us see about the voltage divider rule. Now, about the voltage divider rule means the name itself suggests that voltage is getting divided in a series circuit across each resistance or across each appliance. So here, if I can see that V equal to I into R1, so V1 is equal to I into R1. Now, what is I? What is I? I is the total voltage divided by the equivalent resistance. Now, what is the equivalent resistance? R1 plus R2 plus R3 into R1. This R1 is again replaced here. Similarly, V2 will be equal to V into R2 by R1 plus R2 plus R3, and V3 will be V into R3 by R1 plus R2 plus R3. So in this way, we can see the voltage divider rule, where without involving current, if we are having the three resistances, then we can find out the voltages across each resistance using these formulas. So this is the voltage divider rule. Thank you.